Thank you. So, hi everyone. Thank you for joining today. My research topic is using a macroalgal cultivation system in wastewater bioremediation, a case study of Bolungarvík, Iceland. And this is the agenda for today. I'm going to start with a brief introduction and list up justification, aim, questions, and objectives of my research. Next, we'll go over the methods that were used plus the fieldwork. We will also cover the results and how they can be interpreted in discussion. And finally, we'll wrap it up with some research conclusion. So starting with justification of my research, it is important to point out that remote Arctic communities are often characterized by limited knowledge about hydrology, and information on the coastal pollutants in Iceland, in remote areas here in particular, can also not be updated for decades, and demand for the wastewater treatment systems here is not often established, and facilities become old, and wastewater treatment updates often don't seem affordable. So my research aim here, considering these problems, was to identify changes in the concentrations of pollutants entering the port of Bolungarvík from wastewater outlets, and test the effectiveness of an experimental plot for which included attached macroalgae species for primary wastewater treatment. And my research questions were framed based on 4 different inputs considered in wastewater management. These inputs included treatment, pollutants, wastewater, and climate. So for treatment, my research questions were: how does the experimental plot affect the change in the concentrations of total phosphorus, total nitrogen, total organic carbon, and total suspended solids in the port waters of Bolungarvík? For the pollutants, my question was: how do these concentrations change with the increase in distance from wastewater pipes? For the wastewater itself, my question was: what is the volume and discharge of wastewater in the research area? And in regards to climate, my question was: how does precipitation affect the concentrations of pollutants in wastewater? And what is their share in the total volume of wastewater? So my objectives included work on the different sorts of applied and analytical tasks. And these tasks included those that outlined here on the slide. First was to conduct a comprehensive description of the area. Second was to introduce a simple and reliable method of calculation of wastewater volume and discharge for the research area. Third was to identify the main pollutants from the pipes. Next was to design and build the experimental plot using recycled materials provided by the local communities, attaching the locally grown macroalgae species to evaluate their potential for the wastewater treatment. Then it was to evaluate the changes in concentrations of pollutants next to the pipe that was affected by this experimental plot. And lastly, to evaluate the effectiveness of the plot from the perspective of the current anthropogenic pressure on the water. And now moving towards my methods, my research basically began with presenting the project at the mayor's office in Bolungarvík. And after getting approval, I started searching the area for the experiment. It was decided to focus on this part of the port of Bolungarvík, where we can see 2 wastewater outlets. And outlet number 1 was considered to be the test pipe, in front of which I would put my experimental plot. And outlet number 2 was considered as a control pipe, where the concentrations were changing like naturally. Next, I started to consider the location of the plot itself, relatively the first outlet. And there were several factors affecting on the decision-making process here, like maritime traffic, accessibility to the key port infrastructure facilities, tidal regime, wind and wave regime, distance from the wastewater outlets. And considering these factors, it was decided to place the plot in front of the test pipe at the distance of 15 meters. So next, what I did was I deployed 4 data loggers in different places in the port, in the water. They measured temperature and light intensity with the frequency every 30 minutes from January 2021 until February 2022. They were located at the different depth ranges. So first couple of loggers were located close to the shore, and average depth was around 1 meter. And the other 2 were located more in like deep water environment with the average depth of like 8.5 meters. And the distance from the coastline at the shore was around 6 to 7 meters. And on the slides below here, you can see some work process of how these loggers were assembled using recycled materials. It's basically some of the fishing gear, fishing ropes, then some recycled metal material, buoys that also were provided by the fishing company that were going to be recycled further, if not to be used. So next couple of words is about the design of the plot itself. So it included the combination of buoys, floating pipe frame that also was picked at the local recycling facilities. Also included anchors, different kinds of ropes, cultivation lines. I also went and picked macroalgae species called Saccharina latissima to attach them in a kind of way that is presented here on the pictures. And total weight of the anchors that ensure the stability of the plot on the water was around 700 kilos, which also included recycled chains. They were made of recycled chains. And the summary of the main parameters of the plot are located here in this table on the right side. And the main distances between the cultivation lines were like around 5 meters. Between the cultivation verticals in the water column, it was about 2 meters, and floats were pulled on the cultivation lines through every 4 meters. And yeah, all the rest of the lengths are also presented here. And this is just a brief demonstration on how the deployment was going on. So after getting the permission on the work day from the harbor master, firstly, we deploy the anchors at designated spots using the port equipment. Next, I brought ropes, buoys, and the pipe in the water, pulled them together at the designated spots and attached them all together. The work took the whole day, and in the end of the day, it looked something like that, which was considered pretty close to the design sketch and was considered acceptable. And here's the brief description of my sampling strategy for the assessment of the water quality. The sampling calendar is presented here on the left of the slide, on the left side of the slide, and it included 5 sampling events in total from October to February. And the first sampling was the pilot water sampling and included the entire area of the port itself. And starting from the second sampling and until the end, I was focused more on getting the samples in front of the pipes in the area with the experiment. And basically, 2 samples were taken in front of the test pipe before and after contact with the plot, and the other 2 samples were collected at the same distance at the control pipe number 3 and 4 right here. So information on the lab protocols is also provided here for the record. Basically, I took my samples, sent them to lab in Mattis in Reykjavik, and from Reykjavik, they sent it to the lab in Sweden, and they ran the test in the lab there. So what they tested was total phosphorus, total nitrogen, total organic carbon, and total suspended solids, according to the standards that they used. They are provided here, and the brief descriptions of the methods that they used in the lab also just outlined here, just for the general information. So once I received all my samples, I was able to start the statistical analysis. The first step there was to prepare data set and upload it in R, with calculating differences of concentrations between the test pipe before and after the contact with the plot, and the control pipe at the same lengths, points 3 and 4. And my second step was to evaluate the statistical assumptions of independence, normality, equal variance. And considering that all three statistical assumptions would have been met, I would run with the 2-sample t-test. However, one of the assumptions wasn't met due to some reason. It was assumption of equal variance, and therefore I was advised to run with the Wilkinson rank sum test, and the goal there was to determine, is there any significant difference between the reduction of concentrations between the two sampling areas. So finally, to perform wastewater discharge and volume assessment, I calculated annual volume and discharge of domestic water using the guidelines provided by Veitur. Did the same for the volume and discharge of the surface water that forms in the area of the town in form of precipitation. And next, I calculated the average load of pollutants from the households operated by test and control outlets. And finally, there was average individual load of pollutants that I calculated from residents of the districts 3 and 4, districts 3 and 4, the areas that operated by test and control pipe respectively. And that was it about the methods. So now we can move more to results. Oops. And I'll begin with the brief description of the thermal regime of the port waters. We can see that the data from all 4 loggers follows the same fashion here. It shows the distribution of water temperature and air temperature throughout the research period, as well as the light intensity. So we can say that basically in January, temperature is relatively the same everywhere, close to 0. Then it steadily grows up towards the summer months and reaches the peak around late August, beginning of September. And the light intensity is mostly the highest in late April or May. So after the summer, temperature drops back from 10 degrees close to 2-3 degrees and stays relatively low until the end of the year. So it shows that basically the distribution of temperature in light intensity was relatively the same in all areas where it was measured. So a couple of words about variability of total phosphorus, total nitrogen, organic carbon, and suspended solids. Here it's we can see that sample groups 1 and 2 are provided for the test pipe with the experimental plot, and samples from the group number 3 and 4 for the control pipe. And overall, we can see that concentrations from the test pipe are generally higher than concentrations from the control pipe for all the parameters. Now, just a brief results on the statistical processing of how the differences between concentrations were varying at test or control pipe. And the figures here show the spread, how these concentrations were changing at the time before and after the contact with the plot. And basically, I found one statistically significant difference, and it was for the total nitrogen. So the test showed that while being statistically significant, the nitrogen concentrations decreased more significantly in the area with the plot located rather than in the area without any plot. So the rest of the figures didn't show any statistical significance, but still gives us the just some estimates on some insights how the concentrations was spreading at these pipes. And now more towards the graphical description, we can see the seasonal changes for total phosphor in the port of Bolungarvík, and concentrations here were built for the period from October 2021 to February 2022. And basically, we can see that concentrations in October, from October till January, and even first sampling in February remained relatively the same. However, in the last sampling event, there was a spike of concentrations of total phosphorus in the February. And a similar picture here for the nitrogen. We can see that the main source in most of the events was the test pipe for uploading these chemicals in the water. And we can see the more uniform picture in January, but however, again, we had a spike in the last sampling event in February that also was coming mostly from the test pipe. Now, moving on to the organic carbon, it's pretty much the same as phosphorus and nitrogen, except that one of the sampling events, the main source considered to be the control pipe and not the test pipe as it always was. And again, in the last sampling event, the concentrations just rocketed. And lastly, the distribution of the total suspended solids in the water, relatively low concentrations in October, December, and January. But in February, the concentrations were much higher again. And the last two events, yeah, like I said, showed pretty high concentrations here. And the last bit before we would move to a discussion was about the quantities of wastewater. So basically for the entire town, there are 9 wastewater districts operated by different pipes. And the test pipe was operating for the district number 4 here. And control pipe was operating mainly for district number 3. And we can see that district number 4 is the biggest in population. It has the biggest area size in the town, most area coverage of houses and streets, as well as open areas. So considering all the other parameters, we can see that average annual water discharge, as well as total wastewater discharge, are the biggest for these districts, basically because of the biggest population and the biggest areas in it. And finally, the average load of pollutants from households and residents here are also provided. And we can see that the loads from the district number 3, number 4 also varying pretty big extent, and the load from district with more people is definitely higher. So there are a couple of things I'd like to address in discussion. So we can see our wastewater districts in the town. There is totally 9 of them. And we can see that the ratios between the domestic wastewater, that's the red color, versus surface water, the blue color, are also presented for each of the district. And we know that the test pipe, the district from which the test pipe was coming from, is the biggest in town. There are more people live there, so there's more wastewater forming, and it can be compared also with the district from the control pipe, where the domestic wastewater input is also bigger than surface water input. And now there was the interesting thing that when I planned this research for that specific period of the year, I assumed that there will be no precipitation because it's winter and most of the precipitation would be in a solid form. And that's what the long-term trends show here for that period of the year. However, the precipitation data combined with the air temperature data here showed that basically runoff occurred on the area, and precipitation could have turned into the liquid form. So basically the snow began melting there. And also, but at the same time, if it all would melt at the same time and being liquid, it also, the concentrations of chemicals would be below the average for the year. But we saw the spikes on the last measurements. So my guess in that case was that precipitation somehow was in the mixed form. So both liquid and solid were affecting the concentrations. And what might have happened in the end, in the last sampling events, that the spike in the pollutants could be caused by cumulative effect of precipitation, and water could start just discharging from the snow, which also can accumulate the pollutants over a long period of time. And finally, when it releases it, we may get certain spikes. And just the last bit on the discussion that I wanted to bring up here is just to compare the anthropogenic pressure on the receiving waters from what we measured in Bolungarvík, and maybe compare it with some international examples. And for that one, I picked the similar municipality with similar population size and nature. It was in southwest of Finland, in Kustavi, and we can see that concentrations on total phosphorus and total nitrogen are presented for Bolungarvík here, and concentrations for phosphorus are pretty much similar to the concentrations that people release in Finland, while when it comes for nitrogen, the decrease of the concentrations in Bolungarvík was much less than in Finland, where there was no plot, I assume. And finally, when it comes to internationally established limits or requirements, we can see that by EU Water Framework Directive legislation, they don't have any specific limits on phosphorus and nitrogen in place for the towns that are as small as Bolungarvík. However, if we use just for the reference the requirements that we have in place for the Baltic Sea, we can see that the concentrations for total phosphorus here are like 2 milligrams, for nitrogen is 35. They don't have any specifics on solids, but our values here are way less than the limits. So wrapping up, I just wanted to highlight the key messages of my research. The purpose of it was to evaluate the ability of the introduced experimental plot to perform primary wastewater treatment in the receiving waters. The proposed plot significantly reduced concentrations of domestic source nitrogen. No statistical difference was found in the reduction of phosphorus, carbon, and solids, which may be due also to the size of statistical sample. The spike of concentrations could be due to cumulative effect of precipitation and water discharge from the snow, and the measured concentrations of nutrients show that the maximum values do not exceed internationally established release limits. So I know that I'm pretty much at the time here, but I wanted to take a second to express my big thanks to my advisors, to all these organizations and all these beautiful people here who made this research possible. And thanks everyone who ever helped me, gave some advice, support, like with whom I had chat about it. And yeah, thanks to you as well, who and I really appreciate the opportunity to share this research with you, with everybody today at this conference. So thank you for your time and attention, and I'm looking forward if there are any questions here.